Hello class, this is the SPSS video for how to do an independent samples t-test. Note that this lab is due on Thursday, April 16th, and something that a few of you missed, whenever you upload your document to Jupyter Grades, make sure that you have saved the lab with your answers according to this specific lab name. The purpose of this assignment of this lab is to learn how to do an independent samples t-test using SPSS. You're also going to practice reading SPSS output and writing interpretations in APA format. I'm going to jump right into the lab this time and get us right into SPSS. We're going to be using the employee data file, so let's open up SPSS. And if you don't know how to get there, here's the reminder. You do File, Open, Data. You'll want to go to the C drive, click on Program Files, then click IBM, then SPSS, Statistics. I believe you have version 21, so click on version 21. Then or folder 21, then go to samples, English. Now you have all the sample data files. Scroll over until you open up employeedata.sav. Now the first thing I'm going to do is show you just how to do an independent samples t-test. It's slightly different than a single sample t-test. The key thing about an independent samples t-test is that you have to have some variable, in this case gender, or perhaps it's job category, some variable that identifies group membership. So males would be an independent group from females. Managers would be an independent group from clerks, which would be independent from custodians. And so in SPSS, to do an independent samples t-test, there has to be two columns, a minimum of two columns of data. One column identifies the category that they belong to. That would be your independent variable. The other column will be your dependent variable. It might be beginning salary or their current salary or their education level that you use as a dependent variable. I'm just going to do a random independent sample t-test. We'll do one, for example, job time as our dependent variable. And we'll ask the question, do men and women differ in their average job time? So just to show you how to do the t-test and how to look at the output. So as always, you click on Analyze, and this time we want to compare means. But instead of doing a one sample t-test, you're going to do an independent samples t-test. So you click that. The dialog box opens up that allows you to select your variables. Your test variable in independent samples t is going to be your dependent variable. So in this particular example, our dependent variable is job time. So we find job time, which I think is months since hire, and we move it over. And then you have to identify the grouping variable. In this case, this is your independent variable. We want to see if men and women differ in their average job time. So we take gender and move it over. Notice that you can't do the t-test yet. It won't let you click OK because SPSS needs you to identify the groups. So if you click on Define Groups, it will ask you, well, what's Group 1 and what's Group 2? You may not remember, looking at the code name, or the name male and female doesn't help. You can't type those in. So let's cancel and go look, and by selecting this value labels, if we go look, we can see that gender is actually coded male or female. I'm sorry, it's coded M or F. So go back to the analysis, compare means, independent samples t-test. Our test variable is going to be months since hire, and the grouping variable is going to be gender. But now we know how to define the groups. We know what their group label is, which is either M or F. When we hit continue, it'll now let us click OK. As always, you can click on some of the options over here just to see what you can do. We don't see anything, click on descriptive statistics or anything, so you just cancel that. And then you just click OK, and now you get your t-test results. As always, it gives you the descriptive statistics first. It tells you that your months since hire is the variable that you've analyzed, how many men and how many women were analyzed, and their average, their means, their standard deviations, and then the standard error of the mean for each sample, which possibly came from a different population. Down here you have the inferential statistics, and there is a portion of this that usually confuses students. It's this Levene's test for equality of variances. They see an F value and a sig, and we always know to look for the significance level, and they think that this is something that's associated with the t value. What these two columns, the F value and the significance level of Levene's test, what that analysis is doing is it's not asking is there a significant difference in these means. It's actually asking is there a significant difference in the standard deviation. One of the assumptions of conducting a t-test is that the variance, the standard deviation of the two populations are equal. Those variances are equal. If those variances are not equal, then you have to modify the analysis slightly, come up possibly with a slightly different result. So what Levene's test for equality of variance is doing is it's simply asking, is there a significant difference between the standard deviations? You want this significance level to be non-significant. You want Levene's test to be greater than 0.05, showing that there's no significant difference between the deviations. If that's the case, if you do have equal variances because they're not significant, 10 and 9 are equal to each other essentially, then you can use this t-value, this degree of freedom, and this significance level. If for some reason the Levene's test is significant, if this p-value here is less than 0.05, then you cannot assume equal variances and you have to use the modified t-value. You see that you have a slightly different t-value, a different degrees of freedom, and a slightly different significance level. Well, in our case, there was no significant difference between the variance, so the assumption of equal variances holds or is true, and so I can use this t information. So if I were to write this up, I would say something along the lines of the average months since hire for men, mean and standard deviation, was not significantly different, t of 472 degrees of freedom, n period, s period, because this p-value is greater than 0.05, so it was no significant difference, was not significantly different from the average months since hire for women, mean of 80, standard deviation of 9.6. That's really all of the data that you have when you do a t-test. Now, you'll notice over here you have a mean difference and a standard error of the differences. That's basically 81.72 minus 80.38 is your difference of 1.34. And it has a confidence interval, but this is a confidence interval around the difference. This is basically saying we assume that the difference in the population means of men and women on this variable is somewhere in this range. So that's the process of doing an independent samples t-test.